All right, guys, last video we talked about horizontal vertical translations and also stretching, compressing. This time we're talking about reflections, and then we're going to put everything all together. So reflections, just like it sounds, you're taking a reflection of the original graph either over the x-axis or the y-axis. If you reflect over the x-axis, the x-axis is this one, right? So if I reflect over the x-axis, that's like a vertical reflection, right? If I reflect over the y-axis, that's like a horizontal reflection. You're reflecting left and right. Okay, what does the thing say? It says if you have your original function, you have the negative on the outside of the thing, outside after f of x is already completed, then that constitutes a vertical reflection, reflecting over the x-axis of the original. What if the negative is inside the function before you apply the squared or cubed or whatever kind of function it is? If it's inside the parentheses, then that's going to be a reflection over the y-axis. So it's a horizontal reflection. All right, let's see how it looks with some examples. So now we're doing questions number 6 and 7. Yeah, 6 and 7. Yeah, 6 and 7. Okay, so let me copy and paste these guys to my thing here. Thing being the technical jargon. Okay, so here's my x-axis, here's my y-axis. I'm doing this, so negative x squared. So original x squared, remember? Oops. Here's my point, 1 out, 1 up on either side, 2 out, 4 up on either side, right? So that was my original graph. This time I'm taking a reflection. The negative is outside after the squaring has already happened. So that's going to be a reflection over the x-axis, meaning it's a vertical reflection. So I'm going to go out and down 1 instead of up. And out 2 and down 4 instead of up 4. Just like that. That's it. That's number 6. Okay, number 7. Let me circle that a little nicer. Okay, number 7, let's do that in purple. So this time the negative is inside before the squaring happens, right? Okay, so that means it should be what we call a horizontal reflection. So where my original value was here, it should reflect over that way. But it turns out that, we have an even function. So when we reflect over the y-axis, remember from the last class, even functions, they land back on themselves. So it actually gives me back the original. Now, if you're not convinced, you can always just make a little table. I'm going to focus on number 7 here. And you notice I'm not always doing tables, but just to, illustrate it. If you're stuck or it doesn't make sense to you, always go back and resort to making a table. If I plug in 0, negative 0 is 0. Square it, still 0. If I plug in 1, negative 1, squared, still positive 1. If I plug in negative 1 times negative is a positive 1, squared, I still get 1. Right? Negative 2 times negative is a positive 2, squared, I'm going to get 4. If I plug in positive 2, it's going to give me negative 2, but squared, still 4. So all the same points, right? So we're just landing right back ourselves after that reflection. So there it is. That's 6 and 7. We've done all the different types of transformations already. So we've done stretching, we've done translations, we just did reflections. Now the last thing to do is put it all together. So this here is the most important part of the whole section, putting it all together here. I don't know why I have all these colors. I don't want this one. Let's choose it. I want a blue one. Okay, so this right here, this formula here is the key formula. And let's because it's so important, let's zoom in for a second and just talk about what's happening. So this is the formula for a whole family of functions based on f of x. And that's the original f of x, but then with a bunch of translations, right? Here, this is a horizontal. And I'm showing you in the order that it's applied. Because why is it this order? Just think about the order of operations. Order of operations says parentheses first, right? Remember PEMDAS, the whole thing? So parentheses first, horizontal translation, either left or right, depending on whether this is positive or negative. It's the first thing, step 1. And then step 2, just looking at my order of operations, next would be this B here, right? So that's step 2. Step 2 is this is a horizontal stretch slash compressing, right? Or compression. And then looking at my order operations, okay, last two things I have is a multiplied and a plus d. Well, order operation says multiplication comes first. So that means next thing would be the vertical stretch or compression. I'll tell you guys a little secret. I honestly, personally, very rarely even use a horizontal stretch or compression if I can avoid it. If it's possible, at all possible, I try to pull this out as a vertical with stretch compression using algebra before I start to write my thing, if it's possible. If it's simple, easy. But yeah, okay, never mind that. Lastly, this is the last thing left. Step number 4. This is going to be a vertical translation, right? So shift up or down. And that's the whole, gives you a whole family of graphs based on the original y equals f of x. And what I just told you a moment ago, that's what I have here, right? This is the order that you do things in, following the order of operations. Horizontal translations, then stretches, compressions that are horizontal, vertical stretching or compressing, and then vertical translations. Oh, yeah. I forgot to mention. So if this B, when you're doing the horizontal stretch or compression, if that B is negative, you'd also flip at that time over the I think I have this written wrong. Oh, I wrote the wrong axes. It should say y-axis. I'll fix that too. Okay, so a horizontal reflection over the y-axis, right? Horizontal reflecting over the center line here, this one. And then vertical reflection, if your A is less than 0, here, this guy, then you're reflecting over the x-axis, up and down. Okay. Now, one last thing. My personal tips for actually graphing. So, I mean, this procedure here, doing those things in that order, is always going to work. And if you want to make a table, this is the method that you should use. But personally, that's not how I approach graphing. What I usually do is I think about what happens to the origin point 0, 0. Because if you plug in the origin point and you plug in something that makes it 0 on the inside, then if this part is whatever makes this 0, like if x is c, then this part inside becomes 0, right? And then you have b times 0, so that b is gone. It's just 0. And then after that, it's stretched, yes, but then that starting position is gonna go straight to plus d, whether it's stretched or not. And so you're gonna find the origin point is gonna move exactly to the point c comma d. So once I do that, then I just think of, okay, now I'll apply my stretching, my flips, my reflections, and then we'll graph the thing. So how do we graph the thing? Well, I kind of showed you before, but like if I'm graphing something that I know if I go 1 to the right, then in the original graph I go 1 up, then I just stretch it if it's necessary. Instead of going 1 up, then I go whatever it is. If it's multiplied by 2, then I go 2 up. Or if it's 2 down, I'll go 2 down. Or if it's whatever it is, right? So I'll show you what I mean in the next couple of problems here. Where we're in problems number 8 and 9 already, right? Yeah, 8 and 9. So I'll show you both ways how it works out, okay? And they're very similar, but just like a slight difference. I think my way is personally easier, but you know, you're free to, as long as what you're doing makes sense, just kind of, you have some freedom in math to do things a few different ways. As long as what you're doing is perfectly logical, as long as it's mathematically correct, that's fine. Okay, so let's do number 8 first. I'll show you number 8 both ways, and then number 9 I'll show you like only my way, because then I'll start being lazy by then. Okay, so number 8, we're gonna start by, let's start with my original function, right? Original function is here, here, here. I keep graphing this thing over and over. In the red. Oh, that was pretty ugly. Yeah, that's pretty good. And this side. Okay, so original function, but first thing that happens is I'm shifting 3 to the right. Yeah, shifting 2 to the right. Okay, so I'm gonna take this whole thing, shift it 1, 2, 3 to the right. If I do it this way, actually, it's pretty easy. Okay, that's that -3, right? Next thing to happen would be the okay, so there's nothing multiplied on the inside here, so I don't have to worry about a horizontal stretching. Next thing would be the multiplied by 2, so it's stretched out. Right. So that means instead of going 1 to the right and 1 up, I should be going 1 to the right and 2 up, right here. So something like this, stretching, yeah? Okay, and lastly, you're moving it up 1. So this whole thing, oops. This whole thing moves up 1, just like that. So there you are. That's the final result. You know, even as I'm doing this, it's really very similar to what I would normally do. But if you're having trouble figuring out how the things work out, again, resort to a table. And my suggestion is to you is to start with whatever number you see here. Now note though, if it's -3, that means the number that you're looking for is positive 3x. What happens if I plug in positive 3x? And then just go to the left and right one. So one to the left would be 2, one to the right would be 4. And then go maybe another one. 2 to the left would be 3 minus 2 is 1. And 2 to the right would be 5. So this is 1 left. This guy is 1 right. From the starting position, yeah. This is 2 left. This is 2 right. Okay, so if I plug in 3, what happens? This part is 0. Multiplied by 2 is still 0. Plus 1 is 1. If I plug in 2, this is 2 minus 3. That's negative 1. Squared is going to be positive 1. Multiplied by 2 gives me 2. Plus 1 is 3. If I plug in 4, this is 4 minus 3 is 1. Times 2 is 2. Plus 1 also 3. Okay, if I plug in 1 here, 1 minus 3 is negative 2. Squared is going to be, negative 2 squared is 4. Times 2 is 8. So it's 8 plus 1 is going to give me 9. Wait, is that right? 4. Yeah, okay. And then if I plug in 5, 5 minus 3 is 2. Squared is going to be 4. So 4 times 2 times 2 is going to be 8. Plus 1 more is 9. So again, 9. So I've got 3 comma 1. That's this point here. 2 comma 3. That's this point here. 4 comma 3, which is right this here. Then additionally, I have 1 comma 9. That's like somewhere over here. So this should have actually connected that way. And then 5 comma 9. This is 3, 4, 5's right here. So something like over here. So this should have actually connected that way. Yeah. So there you go. Okay, that's how you do it. Okay, how do I do mine? Actually, pretty much the same. Actually, if I think about it. Only difference is I start personally. I'm going to redo this question. Same question. I start by just doing the center position. So I observe what is my C and what is my, is it D? C and D? I forgot what they labeled. Yeah, C and D. What is my CD? So in this case, it's the point 3 comma 1, right? So I go straight to drawing that point. That means this original point 0, 0 is going to now move to 3 comma 1. Yeah, so I got my new parabola would be right here basically. But then I pay attention to any vertical shifts or any reflections. In this case, I just have a stretching by 2. So my new starting position right here, yeah. Normally I go 1 up and one to the right, one to the right, one up. But since it's stretched by 2, I go 1 up. I'm sorry, 1 to the right and 1, 2 up. And 1 to the left, 2 up. And normally, so that gives me this point. Normally, when you do a original parabola, right? Think back to your original parabola. When you go 2 out, it takes you 4 up, right? 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. That's the original parabola. But this has a scale factor of 2, so instead of going 4 up, I'm going to go 8 up. So 1, 2, 3, 4, 5, 6, 7, 8. Then put them here. And 1, 2 left. 1, 2, 3, 4, 5, 6, 7, 8. So there's my new parabola. And that matches what, we went through all that trouble making the whole table. It matches, right? That's what it does. Okay, guys, that is it for this video. Almost no, I lied. I'm actually going to just run through FastKind numbers 1 through 9 once more, really as quickly as I can, just using that last method I was telling you about. Okay, so starting with the original function. Original function, our best friend, starts in the origin, 1 to the left, 1 to the right. That means 1 up, 1 up. So you have this parabola like this. Parabola, when you actually graph it, you should really do 2 points to either side plus the center in normally. But I'm going fast, so I'm just gonna do 1 point. Okay, next one, -3 means shifted to the right, right? 1, 2, 3, same parabola, shifted to the right. 1 up to the left, 1 up to the right, 1 up. Okay, next one is +1. So from my starting position, +1 right here, 1 right, 1 up, 1 left, 1 up, right there. This is number 3. So this is number 1, this is number 2, this is number 3. Okay, number 4, 2x squared. That's the vertical trend, vertical stretching. So starting position stays the same. 1 up, instead of 1 up, I'm gonna go 2 up. Just like that. Boom. That's number 4. Number 5, horizontal stretching. So starting position same. The 2 is in the inside. So normally I go 1 up and 1 to the right, but this time I'm gonna go only half because remember it's backwards for the B, right? So it's half, which makes it look like a vertical stretch. Okay, number 6, -x squared. Negative happens afterwards. That means it's a vertical reflection, so it's gonna just open downwards. Left 1, down 1. Yeah, that was number 5 and 6. Okay, number 7. This time the negative's in the inside. So that means from my original graph, I'm going to reflect over the y-axis, but that's going to land back on itself because it's even in this case. Okay, number 8. -3 plus 1. So 1, 2, 3 plus 1 right here. Oh, I just realized, did I skip the last question? I'm sorry, I skipped number 9. I'm gonna get to number 9 anyway right now. Okay, so that, and then took care of the translations. It's a double. So from my original position, out 1 and up 2. And out 1, up 2. Right there. That was number 8. Okay, now last one, number 9. And number 9 I just realized we didn't do already. So let's do it. And what am I gonna do? First, I gotta identify my C. This case, you see how it's a plus? That means your C is equal to -3, because this is really minus a -3. Right, so that means my starting position, and here D is -1. So my starting position, -3, comma -1. So 1, 2, 3, make it a little bigger, -1 right here. Starting position. Okay, now do I have any vertical or horizontal stretching or reflections? Nothing on the inside. Here I have a vertical compression, it looks like, and it's also a negative. So negative means it's going to go upside down. So it's going to open downwards. And a half. So normally I'd go out 1, down 1, right here, right? Out 1, down 1. So I'd have these points normally. But in this case, it's only half of that. So I should go out 1 and only half in between these guys. So only this way, only half. Let's do another point. Normally I go out 2 and down 4, but this time I'm going to go out 2 and just down 2. So like this. So here, connect those dots. And there it is, your graph opening downwards. Right, I can even give points here. This is going to be -3, -1. This point right here is going to be -4 and -1.5. Oh, this is not a good spot to write that. So this point right here, this is -4, -1.5, right? I just went down by 0.5. This point right there, this guy, that's -2, -1.5. What about here? This is -5, right? That's 2 out from -3. And then I went down by 2 instead of normally where I would have gone down by 4. So what's 2 down from -1? -3. And then this point right here, that's going to be -1, -3. Yeah. Okay, that's it. There you go, guys. So I'll see you in the next video. I think is actually the last one already, yeah? Unless you want to split this. So we got these remaining questions left. About 10 more. Actually, 11. I guess maybe we'll do it in 2. We'll see how long it takes, but we'll approach that in the next video.